outPhit is an EU-funded project that is driving future-proof energy renovations in Spain and beyond. The project is renovating buildings through 25 case studies to show real results and provide energy-efficient solutions using the EnerPHit standard. Currently, 75% of European buildings are inefficient, contributing to 40% of EU energy use and 36% of CO2 emissions. The goal of the outPhit project is to make buildings climate-proof. The project was shortlisted for the Innovation Award at the EU Sustainable Energy Week this year. During the event, I had the opportunity to discuss with Sarah Mekian, Communications Director at Climate Alliance, about the project. Here is what we discussed. Hello, Sarah. Thank you for joining me today.
Thank you for having me.
So, outPhit, can you please give us an overview of the project and its main objectives?
Yeah, okay. So outPhit started when a lot of experts that have been working in the field of energy efficiency in buildings, more particularly passive house, and retrofits that are in line with passive house principles. We call this the EnerPHit standard. They're professionals. They've been doing this for a while. And there we're looking for ways to make renovation faster, more cost-effective, because that's one of the giant stumbling blocks. And on the other side, there's this movement, maybe you've heard of it, called Energiesprong from the Netherlands. Very fascinating, impressive, where they can do whole renovations of really large projects in a matter of days. It's cost-effective when you can get it all done in the factory and then just kind of plug and play on site. You don't have to have tenants move out. So there are a lot of benefits, but this wasn't attached to any quality standards. So
exactly,
the quality that was coming out of these Energiesprong projects was hit and miss. So the project team kind of said, well, what if we could combine it? What if we could take prefabricated modules, this idea of Energiesprong, and align it to passive house principles with the EnerPHit standard, and thereby get really, really high quality, high performance, energy efficient retrofits that we know work faster and more cost effective.
You just mentioned the EnerPHit standard. Can you please elaborate a little bit? What is it?
Yeah, okay, so in order to talk about EnerPHit, we should probably go back to passive house. Mm-hmm. In order to talk about passive house, we need to go back to first principles. So good building physics is pretty much what it is, right? I mean, it sounds fancy and high tech. What I love about it is it's actually very, very simple. Electrons work the same way around the world. We just need to make sure that we honor the way building physics works. And so that's what the passive house standard does. It pretty much quantifies how we can do this. So you need really good insulation. And how much insulation you need depends on where you're living, what your climate's like. You need really good windows. That's also part of the building envelope. So for most climates, you're looking at triple pane, not double pane. You need air tightness. So let's make sure that our building's not leaking energy. And that's kind of an attention to detail that a lot of people just miss. You also need good ventilation. But if we're going to do ventilation, let's make sure that we're not wasting any energy in the process. So let's do it with heat recovery. So you take all of these elements, and pretty much those are passive house principles. And if you apply them to renovations are more challenging because you're dealing with something that's already there with all of its flaws and characteristics. Then we call that the EnerPHit standard. And so what passive house does is says we want to make the final energy demand, so the energy that comes out of the wall, we want to have that 15 kilowatt hours per square meter in year. What does that mean? That means if you're looking at heating load, like I could basically heat my living room, that's about 24 square meters, typical living room size, I would say, a larger one, with 8 tea lights. Okay, we don't want to do that.
Yes.
or a 130 square meter house with the power that it takes to run your hair dryer.
Okay, that sounds too good to be true, to be honest.
I live in one. It's not too good to be true.
Nice.
So that's passive house. And then taking these ideas and applying them to renovations is EnerPHit. EnerPHit, you can go either by looking at least 25 kilowatt, not at least, maximum 25 kilowatt hours per square meter in year. So it's more than the 15. Or you can say, okay, I just use really, really high quality passive house-like components throughout the whole project, and then it can be EnerPHit as well.
And you said that it doesn't matter where in Europe you live.
No.
You can be, let's say, in Norway and have a minus 30 or 20 degrees Celsius, or in Greece and have a 43, like we're having this week. And again, Enerhouse would be able, let's say, to adapt the buildings?
Like I said, so electrons work the same everywhere. When you're talking about, the standard was created in Central Europe, so a lot of the focus was on cooling, but luckily what keeps a house warm in the winter, or a building, because we're not just talking about residential, but what keeps a building warm in the winter is also what's going to keep it cool in the summer. So if you make sure that it's well insulated, just like a cooler that you take on a picnic, keeps your items cool, as long as you make sure that you have good external shading, you don't let the energy in the building, right, to overheat.
Absolutely. But this brings me a little bit in the innovative approaches that this project has. How does it incorporate prefabrication?
Yeah.
Because this is a huge thing, right? And streamlined processes in its renovations. We have a building that's already there with its flaws.
Yeah. Okay, that's a big question. Let me rewind just a little bit though, and even take this out of Europe. There are passive houses in Africa, across Southeast Asia, in Canada, polar regions. So it's really worldwide, and it depends. The standard works so that it's not prescriptive. It's not you have to build with this material and you have to make it look like this. It's you have to reach this bar. And there's recommendations. So in order to reach this bar, this 15 kilowatt hours, or if we're talking about renovations, 25, then for this type of climate zone, we recommend insulation that has this U value. So that's how it works. Bringing in the prefabricated part, that's difficult because the market's not yet there. So that was kind of the innovation of this project. Talking to the manufacturers who do this anyway and saying, look, can we make your product a little bit better? Can we make the insulation a little thicker? Can we make the windows a little better? And then it would fulfill this standard and be even higher performing. And that didn't work throughout Europe. In Spain, Greece, it was very hard to find manufacturers who would do that, and the products.
I can imagine, yes.
Yeah. So our partners went ahead and did a standard renovation, but to the really high quality standard, to EnerPHit. And that's what was focused on in the award entry. They focused on one of the projects that we have in Spain. But in the Netherlands, it was completely prefabricated. In France, there's a case study where it was half prefabricated, so they did the backside prefab and the front side was historical, so they couldn't. So
basically, you have your key studies, you have your results from some of them, you know how to move forward. So I want to ask you, what are the key criteria for the renovations?
In which sense?
Like, for example, heating energy demand, cooling energy demand, renewable primary energy demand.
So that's pretty much energy.
Exactly.
That's the EnerPHit standard.
Yeah.
25 kilowatt hours per square meter in year.
So what's the focus?
Is the energy demand, heating energy and cooling energy more or less as well. Unless some of them did it with purely passive house components, and then it might be slightly different. But that's the main bar. And then there's requisites for air tightness. So with EnerPHit, you're looking at 1 air change per hour under pressure of -50 and +50 pascals. Yeah.
No need to go to technical.
We don't need to go
right
in
now.
there.
Yes.
But there's a few different criteria that need to be fulfilled. But the main one is really this 25 kilowatt
Perfect.
hours.
Let's talk a little bit about the money. Is it cost efficient? Can a low-income household afford to do it?
Yeah. Okay, so can they afford to do it prefab? It depends on if the market's there. And right now, that's what's being developed. And it really depends on where you live. If I find that you really need to look at the life cycle of the building. So the majority of money that's spent is not really up, and heating energy demand is not really up front. It's over the use phase. So yeah, it pays off, definitely. And we, in the project, there's social housing companies that are building EnerPHit passive house for €5 per square meter rent. So, I mean, it's doable. Yeah, it's just, and also too, I think an important message is you don't need to do it all at once. So somebody who doesn't have a lot of funds and is looking to maybe replace their windows because they're old, but you know what, the roof is just fine, then replace those windows, but make sure that you pick good windows. Make sure you do go for the triple pane, you go for the airtight. And with your next step, also make sure that you do the most you can when you do it, because you're not going to touch that window again for the next 30 years.
So it's something that, let's say, a household can do also in stages and not all together.
For sure,
Oh,
yeah.
That's great. And what are the future goals of the project?
Well, I mean, generally is, of course, raising awareness, getting the market, when it comes to prefab, kind of getting the market there. But there were a lot of quality assurance aspects as well. So coming up with certification criteria to make sure that this is the design that the designer planned. Will it, as planned, meet the standard so that we don't waste our money and our time? There were a lot of guidelines that were made, like summer comfort. How do we ensure summer comfort? So there's now a whole summer comfort guideline. There were a few tools, like how do we look at embodied energy and what impact does that have on the whole life cycle? There's a tool that's going to come out soon for its decision making for renovations. So somebody who's a complete layperson and is looking to do something with their house, they can plug it into the simple tool and kind of get an idea of what's possible. So there's a bunch of different tools, guidelines, criteria, things that kind of flank the case studies, but the heart of the project was the case studies and showing the before and after, showing this 10 to 15-fold reduction in energy usage, showing that before there was mold, and the mold on the walls mirrored exactly where the thermal cameras showed that it was cold. All the cold corners had mold, no surprise. And we even did tests of the air quality to see if there were spores, and there were.
Yeah,
a lot of these were not hygienic places to live. We had case studies where in Spain and Greece, the average winter temperature was 7 degrees.
Yeah. But that in the north, I would say, for Greece at least.
Yeah. But sometimes also like 13. I mean, really uncomfortable situations that you wouldn't want anybody to live in. We also had people dealing with energy poverty. This one woman in Greece couldn't pay her energy bills. She said she had to pay $5,000 a year for heating oil. That's gone now. Now that the house is renovated,
That's not needed.
It's not an issue. So lifting people out of energy poverty is also.
Yes, absolutely. Because in climates like the Greek one or the southern Italian one or Spain, we're not used to battle, let's say, cold. It's quite warm. So our houses are built to keep the cold outside in the summer. So in the winter, even if outside it's not 20 degrees, inside the house will be cold. I have experienced this personally.
Yeah. And to your point, I mean, I think it's really interesting. People in Northern Europe, they always think, oh, well, Southern Europe is warm in the winter. the houses are colder.
Exactly.
And that's
Exactly.
because of the building quality. Now, this case study in Greece, amazing. Last year, you might remember there was this heat wave across Greece.
It's still ongoing. This
Yeah.
week we have 43 degrees in
Oh
Greece.
my.
Yeah.
Yeah, and
So-
that's the new normal.
Yeah, that's the new normal. So I would assume that your project will also have to adapt to this new normal because the southern parts of Europe are becoming more deserty like.
The northern ones too, either that or floods.
Exactly.
But the thing is, building like this makes us more resilient for heat, for cold, for energy independence, for many factors. But going back to the Greek example, last year when we had weeks and weeks of average temperatures that were over 43 degrees, the average soil temperature was like 52. The renovated house from this project had constant 27-degree temperature inside, which
Perfect.
yeah. So it works. It's
So you have the case studies, you know that it is possible. What were the main challenges you faced, if you have to pick one or two? Was it policy that it's not helping you, let's say, progress? Was it the buildings themselves, some of them built like in the early 1900s? What was it?
yeah. If you look at it's different for each project, but I mean, if you look at the one in Spain, it was historical. So and it was kind of when they deconstructed it, it was made out of a mix of different building materials, which made it very challenging. So every project has its own challenges. A lot of the difficulty came in convincing people of, is this really worthwhile? There was this one project, I think we need to talk about our failures too. There was this project that was going to take off in Austria, and we presented to them all of the benefits, but the people just it would have raised their rent by I think about €2 per square meter, and these were poor people, and they couldn't afford it. They just couldn't afford it, knowing that their building was going to be demolished in 10 years and they would be forced out of their homes. They still voted against it. And then, yeah. So that was an issue. I know in the Greek project, they asked the whole neighborhood, the whole area, hey, you want to get in on this? Nah. They just did this one building. Now all of the neighbors are into it.
Yeah.
They want it as well. Except for the funding is no longer there on the national level.
Yeah, that is a big issue. If the funding is there, I think that the residents will be more inclined to accept it than if it's not there. Let's also be honest. In the South, especially, the economical crisis may be over, let's say in paper, but technically it's still there. So people can't afford to renovate their houses. Or at least they don't consider it a priority.
They don't consider it a priority. I mean, it's nothing against, I say these people, nothing, we're all human, I mean, we'd rather spend money probably on the latest gadget than
also
get installation. That sounds so boring.
Yes, or sometimes on food, right? Because it is quite, this is also a part of the problem. There's not enough money. There are families out there that actually have to choose between staying warm and eating and feeding their kids. I know it sounds a bit cheesy now, but it is true, unfortunately.
It's true. And for me, the only way that we're really going to take care of them, if it's not through giant subsidies, is really by making sure that they don't have to spend money month to month on their heating and cooling bills.
Perfect. Exactly.
So
if you had a magic wand, let's say, and you could change one thing, what would that be? But it has to be one. You need to prioritize.
Can I get political?
Yes, absolutely.
I would like to change the way people see the energy transition and the challenges that face us, that it's not going to restrict us if we act now. It's actually going to free us if we act now and vote accordingly. I think that's what we need, and unfortunately I see the trend going in the other direction.
Let's hope for the best. It didn't go as bad as we feared.
That's true.
So let's close with this positive note that it's not as bad as we feared.
Yeah.
And thank you so much for this conversation.
Thank you for having me here.